Okay, in the last video, we were attempting to solve this integral here, and this denominator, we were able to express as prime factors to get this, and so this integral here, which we use partial fractions, turn into these two integrals here, and this one here we solve. So let's make some more room here. This integral right here is the natural log of e to the t divided by e to the t plus 2. Now we have to solve this integral. So let's make some more room. And it looks like it's going to be the same story as when we dealt with this integral. Here we have minus the integral of dt divided by e to the t plus 1. And again, we try to handle this with a u-du type substitution. We say let u equal e to the t plus 1. du will equal e to the t dt. But there is no e to the t up here. We can say now dt equals 1 over e to the t du. But on this side of the integral, we don't want things expressed in t. We want things expressed entirely in terms of u. But we go back and look at our substitution. E to the t equals u minus 1. So we can put this into here. Now we have an expression for dt expressed entirely in terms of the variable u. And this we called u, so we can rewrite this integral of minus 1. And dt is this. We'll have du divided by u minus 1. And this is u. So now, this integral here is the integral of minus 1 over u times u minus 1. It looks like, once again, we have to resort to partial fractions. So let's see. We're going to have minus 1 over u times u minus 1. Both are linear factors, so that will equal a over u plus b over u minus 1. Multiply through, and minus 1 will equal a times u minus 1 plus b times u. So let's see, collect terms here. Minus 1 will equal a plus b times u. And it looks like we're going to have minus a. So from here we have minus a equals minus 1. So a equals 1. And there is no u term over here, so this has to be 0. So if a is 1, b has to be minus 1. So let's make some more room here. We should be able to get this wrapped up pretty quickly, it looks like. Here we have A over U, 1 over U, and here we have minus 1 over U minus 1. So this integral here minus the integral of du divided by U times U minus 1, that will equal the integral of du minus the integral of du divided by U minus 1. And of course, this is just going to equal the natural log of U minus the natural log of U minus 1. Now let's go back to our original substitution. Back up here, this is what U is. So here we have the natural log of U, that's this. The natural log of e to the t plus 1 minus the natural log of U minus 1. That would be this, which is just going to be e to the t. And we have minus this log, so this could be written as natural log e to the t plus 1 divided by e to the t. Subtracting logs is the same thing as dividing. So this integral here with a minus sign before it now becomes this expression here. So we have, going back up to here then, this integral here is plus the natural log e to the t plus 1 divided by e to the t. So this plus this is a solution to this integral, and of course we can have an arbitrary constant integration. If we want, we can combine these two together. We'd have the natural log of this times this. This is certainly an acceptable answer here. Again, it took a little while to get you there. The calculations involved were pretty straightforward, but we had to apply our technique of partial fractions several times before we could get this into a final answer. But there it is. Hope it was worthwhile. If you have time, come back for another video. We're going to try and tackle a problem that's even more complicated.